As the first step in this example, we're going to create a surface and panelize that surface. So we're going to create the surface by creating a line by start point and end point, and then translating that line just up to create an upper line, and then create a list of those two lines and loft those together to create our basic flat wall surface. Then we're going to panelize that surface. And we're going to do that by setting up the familiar panelization parameters that we've been using on many examples. We're going to set a number of panels in the U direction and a number of panels in the V directions and choose the family type to use for the panelization. Then we're going to build this very familiar node logic. We're going to set up a code block from 0 to 1 to the number of panels plus 1. And it's important to kind of remember that when we have the number of points, which are going to indicate the panel edges or the panel boundaries, we need to basically add 1 to the number of panels to get that number of points. We're going to use surface point parameter to go through and kind of place those points, remembering to set the lacing to be cross product. Then we're going to use our quads from rectangular grid and flatten that list to create the list of the quads that we can then panelize with. Now we're also going to take a look at how we can create something called a custom node, which will let us take some of that familiar logic and encapsulate it in a very nice reusable form that will let us kind of just have inputs and outputs and have a reusable subroutine that we can kind of apply in a lot of different examples. So let's go and get started and take a look at how all that works. So if we come over here to the Dynamo and the Revit environments, you'll see I have an existing wall here, but I'm going to basically clear the palette by selecting all instances and just getting rid of that. Okay, now we have a clean slate. Let's go through and take a look at this logic. It's going to start by just lofting to create this surface. Into loft, we're going to set basically an origin point and another point about 50 feet away, which will be the length of the wall. And we'll just basically connect those together with a line. Okay. We'll then also go through and just translate that second line. Okay. So we'll have the lower boundary of the wall, the upper boundary of the wall, and I can just create a list of those two things and then loft those two things together. And that'll just get us started. Okay, so far so good. Just two different lines and a surface that's going through and connecting them. Okay, now we want to think about actually going through and doing some panelization of that surface. So the way we've done that in some of the prior examples is to set up a number of panels in the U and V direction, creating a little code block, which creates a series going from the number of panels plus 1. Okay, 0 to 1 to the number of panels plus 1. We're going to basically take that surface which we've created and connect it in with surface point parameter. Okay, setting the cross lacing or lacing to be cross product. There's a little XXX in the corner of that node to indicate it's the cross product. Then we'll actually just take those points, quad them, and flatten that list. Okay, so that'll hopefully look very familiar to you. And if I run that logic, you'll see I get a nice kind of a series of a nice grid of points on that wall just waiting to be used to place some adaptive components. Now the node for actually placing the adaptive components is here also. It's just a little further over to the right because I'm leaving some space for some things we're going to do in the next step. There it is. So let me just go ahead and see if I can zoom out and connect things together. That's kind of a useful technique, is if you can sort of spot and remember where the different nodes are. I can just basically take that node, which is the points, and bring them over here, and I'll run that. Okay, and I now have a nice list of rectangular seamless panels over there just waiting for us to do something with them. Now, that's such a familiar and useful chunk of logic. I want to actually think about making that a little bit more reusable, and let me show you how we can do that. It's using an operation called creating a custom node, and we're going to do that in several instances. What we're going to do is basically just take this chunk of code right there that's in that group and make it repeatable, and here's how we do that. I'm actually going to use the little control drag to make a second copy, because what I'm going to do actually replaces the code with a node. I will choose that code in that group, and I'll say that I want to create a custom node. And what's going to happen is it's going to give us the option of giving this thing a name. So it's going to be, I'm going to call this quad panel points. I tend to give things the noun. Then I give it some sort of verb describing how we create it, the method basically, by U panels and V panels. Okay, I can give that a category like 220C, or you can give it your own custom category if you like. Say OK. And you'll see what Dynamo does is it replaces our logic, okay, with this. It's like a node that basically has all the inputs to that logic and an output. You can edit that by right-clicking that and say Edit the custom node, and you can actually see the logic that's underneath it. You'll see that all the things that were coming into the logic are now set up as inputs. All the things that were going out of it, it's set up as an output. It doesn't really have a name right now, so we can give it a nice name. I'm going to call it, this is going to be my quad panel points. That notation of a name followed by the semicolon or the colon, and then some declaration. In this case, it's some sort of a data structure. Okay, just basically will now appear on the node. So let's take it back over to the main graph. And you'll see that down here, it's now quad panel points with a name, and it basically has the inputs and the outputs that we specified. I'll pop back over to it. Now you'll want to save these custom nodes away, and where I'm going to recommend saving them is put them in the same folder as the example you're working on. So for example, I'm going to put it in the example for a 43A1 folder. I'll just save it there. The reason you want to do that is that, like, when you open this example later or open this Dynamo graph, it'll look for that custom node, and the first place it'll look is in the same folder where things are co-located. So that's a good place to go ahead and start things until you start creating kind of a standard place to put all your custom nodes on a machine that you work on all the time. Okay, so we have that looking pretty good. Let's come back over. Since we have our custom node, we can actually sort of replace a little bit of our logic now. Rather than using our brand new one that I just created, I'm actually going to use the one that I created just as part of the example that's already loaded in there, just so you get a sense of the same thing, where I can basically take my surface, bring it down, my number of U panels, my number of V panels. Okay, those are all the inputs. I'm actually going to disconnect this one just so I don't have two duplicate copies of the panels floating around. And then this is going to go through and create these quad panel points. Now to swap that in, let me go through and take this and bring it as the replacement for the quad panel points there. Great. So now I basically have reconstructed the logic using the custom node as opposed to all those individual nodes. Let's give that a run. Things are looking good. Okay, let's end there with this first step, and next we'll take a look at how we can go through and select some specific panels so we can, make a pattern out of them.